Good morning. Yay! All right. Yeah. That's what I thought. Yeah. Yeah. That's what you can do. I have no clue. What do you guys? I want to join in the conversation.
Valentine's Day bracelets.
No.
Yes. So, are you getting married for Valentine's Day?
No, I don't have anyone married.
Huh?
Married on Valentine's Day.
Oh, Abel last year.
Yeah. Actually, a lot of people did.
They got ring toss. Yum.
Anyway, all right. So, we did this yesterday, right? So, when we were trying to find FU, remember? Everyone enjoyed finding FU?
Yes.
Yes, it was fun. All right, and then figured out what U was from FU. Now, we're going to find definitions. So, average value of a function over an interval. The average. Now, see that the symbol where it says y bar? Look at the y. Look closely at the y. Yeah! Guess what that's called? No, it's not called a thing.
Average value.
Nope, try again.
A bar over the y.
Yeah, y bar. Yeah. Yeah, so y bar. Anyway, they're super creative on this. All right, so let f be a function that's continuous on a closed interval from a to b. The average value, okay, y bar of f over ab. So that's a symbol for this, the nomenclature, so you have to understand. So the y bar is going to be the average value of the integral from here, okay? So it's basically, I do the integral, then I multiply it by 1 over b minus a. That's it. That's the average value. Okay. So there's mean value theorem. All right, don't forget like, share, and subscribe. No, just kidding. All right, so let's go ahead and do this. So average on this one. So b minus a, right? 1 over b minus a. So write out my function. What did it? Ah, no! It actually worked again. I know, right? It finally did the transition again. Yes! I got it to work. Watch. Bam! Woo! Ah, suck it. All right, anyway. I have no clue. All right, so let's go ahead and do this. Do you remember last time it happened?
No.
I think it happened once in first semester, and I couldn't get it to do it again.
What happens if you go up? Up. So it won't choose that way. Wow.
Epic now. All right, so anyway, all right, let's go back to, let's do math now. All right, so it's going to be y bar here. Y bar is equal to 1 over b minus a. My b is 2 minus a, 0, integral from 0 to 2, thank you, of x cubed and dx, thank you. So my integration is going to be, actually, let's start at the very beginning. So for this one, it's going to be 1/2, and I'm going to bracket this. Okay, I like bracketing. Anything I take out all the way, I bracket, then I just do my integration inside with parentheses, and then I multiply the half at the end. Okay, it makes life a whole lot easier, so I just bracket it out. Because parentheses is kind of annoying. We have to do that on the calculator, so. But yeah, it just means the same thing. Anyway, all right, so that's going to be, okay, what is my power going to be? 4. So it's going to be x to the 4 over 4 from 0 to 2, right? All right, top minus bottom. So it's going to be 1/2. Top, okay, 2 to the 4th is going to be 16. 16 divided by 4 is 4 minus the bottom. So 0 to the 4th is?
You.
Divided by 4 is?
0.
Okay.
How come we don't close the brackets? On the top one?
Actually, I did.
That's the closed bracket?
Yeah. It's not really a closed bracket, it's just bar. Yeah, because it's the end of that there. So you can, but I don't know, it's just weird notation thing that I do, and it's, a lot of people actually do it in math. Because you open it here, but that's the end. So, yeah. Anyway. Alright, so, what's my answer? 2. Okay, so, what does that mean?
Yeah, value is 2.
You're just playing with it now.
No, I'm not. Shh. Okay, so I thought I had a graph for this one. Yeah, so the average area is going to be 2.
From 0 to 2.
Yeah, the average area is 2.
Why do we care about the average area when we can just find the area?
No, I'm trying to find like a specific for this one. There's a bunch that are in like the word problem ones that actually do go along with this, and I just it's like when you meet someone and that you've known for a long time, but then you're like, man, I called your name for like 5 years straight, and then it's been like 6 months and I can't remember your name off the top of my head, and so you're like, yeah,
So they're the average.
what's up, guy? Yeah. So anyway, so just because you asked me right now, I totally forgot.
Okay. Oh.
So yeah, there is plenty of examples in the book with the word problems that they use. So there is reason for it. Yeah, I just completely spaced it right now. So
You're gonna remember in like.
I know I am gonna remember. I'm gonna look at the problems and be like, oh yeah, it's all those. Yeah, but right now, yeah. Anyway, so can you math it?
Yeah.
Yeah, super easy, right? Oh crap! No, sorry.
Wow.
Interpreting integral involving rectilinear motion. Now, it sounds like a bad word, but it's not. Okay.
What?
Rectilinear motion. Okay, what do you think that is?
Rectangle
Your
moving
bike
in a
has
straight
to
line.
move.
Wow. Okay, wow.
The farthest point?
Anyway, all right. So it's basically we're starting on a graph and we're doing movement along a graph. And if we're doing movement along a graph, we're starting at the origin, not rectum. Rectum nearly killed him. Anyway. All right. So okay. Wow, you just got that. Wow, she got Takis coming out of her nose now. Wow. Okay. You're laughing. Okay.
Okay, I'm good with it.
Okay, you're good? Alright, anyway, alright, so we're starting at the origin. We're starting at the origin, and our motion is going in terms of time. Okay? So we're going a direction, so it's usually going to be the positive direction, right? So in terms of time, so over that time, I have a movement because time goes forward. Okay, it's not going backwards. So we're starting there, starting at 0 in terms of time. So that means that my x values are going to be t's, right? Yeah. Okay, good. Okay, so for an object in rectilinear motion moving with the velocity v, v. What do we know about v?
V is the derivative
Of the?
function.
Yes, but in the sense of physics, we don't call it the function, we call it the
Velocity.
position. So we have position. Okay, so in our steps, it's position, right, is my function. Then the next one down would be the velocity, right? After that is the acceleration. Okay.
So,
Huh? And the fourth one is
Altitude.
jerk.
Did we ever get altitude?
no, that's position.
Oh.
Yeah. The next one is jerk.
And then
So-
there's no more after that.
There actually is, but it's not used. Like I actually had to look it up one time, and I was like, yeah, it's like super abstractness, and it's kind of like, yeah. How many times have you ever thought about for your math to work, you have to use 4 different dimensions?
What is a
When
fourth
you're in
dimension?
space.
Huh? So yeah, it's like that. So it's one of those things that everything that we have in space is 3-dimensional, right? Okay, technically, if we're going by Star Trek Fleet Command, it is the 4th dimension is time. Because you're going to be in the X coordinate, the Y coordinate, the Z coordinate, which is the up and down, and at a certain point would be time.
It's like you're spinning and you're gonna be there, but you're not
But don't we
there.
make up time?
Yeah, time is constant.
No, it is not. It is not constant. It is not constant because time, the faster you go, there. Okay, you know that gravity affects time. It's not constant. You know that people in the International Space Station,
Yeah.
okay, they're actually aging less than here because they're going so fast. Okay, I think was it like every 3 hours they make a lap around the Earth? Something like that. That's how fast that they're going. Okay, so now, but think about the circumference of the Earth, right? So big guy in a belt, right? So with a belt, so going around, okay, they're going so fast. The faster you go, slower time goes. You know that if you are able to travel at the speed of time, time almost stops.
So your
Time
body,
almost stops.
So your body.
your body would stop, like,
But
moving or, like,
if you are able to travel with, okay, so speed of light, okay, if you're traveling on a light, some way, some capacity, you're able to go with that. Okay, so your gravitational field in that is not affected by the fact that you're going so fast. Okay, so think of it like this. So everyone's on a train. Okay, everyone's on a train. The train just so happened to be going, okay, the speed of light.
Alright,
Okay, this is an analogy that Einstein actually talked about. You're going the speed of light, and so if you're going the speed of light, you are all around you outside the train is almost at a standstill. It's all, yes, okay, because how fast you're going. It almost at, everything else is at a standstill, but time to you is different. Time to you is different. So this is actually a mathematical thing that they do with geosynchronous clocks. Okay, you know what the satellite clock, like when you have like a GPS and it syncs your phone and stuff like that, when it's off time, yeah. Okay, so what they do is, because satellites run at a faster time or a slower time. So the first time they actually did one of the space missions, they had two clocks, atomic clocks, which are down to the femtosecond or something like that, which is ridiculously accurate. They were completely synchronized, and they were off by a whole second. When that other one, when that second clock went, and I think it made like 2 revolutions around the Earth or something like that. One of the first satellites, okay, when they brought it back, it was off by like a whole second. So time was slower the further you go. So closer you get to gravity, the faster time goes. So in a black hole, okay, time is, this is according to Hawking, one of his books that he did. Time actually in a black hole, it goes so fast that it doesn't exist.
So you just go time?
No. Time doesn't exist. Period. You don't.
Yeah.
move forward
Okay.
or
Because
backwards.
So the more gravity, the faster the time. Less gravity, slower the time. So
And black hole has infinite gravity.
yes, it's all gravity. So yes, time is actually, our time is a social construct
Yeah.
based on our gravity. So if we were to go colonize Mars, which has slightly less gravity, time would be different there. So your body would age differently there.
So your body just adapts
It-
to the.
Okay, so a relativistic, so we would actually gauge everything like, how old are you? Okay, I've made, 42 revolutions around the sun. That's why I make that joke. Okay, here, but then over there, the revolutions are different, but the gravity's also different. So you're aging, your body ages slower. So the time relativity here is slightly different. So
would it really age slower? Or is it just
because gravity is stronger on
Earth,
than on Mars.
your bones.
Your bone density would be different too. So
you'd be taller.
yes, but you would be weaker.
Yeah. That's what like all the astronauts have from.
Yeah,
like, months.
yeah. That's why they have to work out every single day. Otherwise, because they do lose bone mass. Yeah.
All the people watching this are bored.
So you're gonna have a
No one cares.
I know, it's only gonna be Patar anyway, and you know what he's gonna do? He's gonna come in during advisory and put it on loud as KB on one of the computers, because he knows I hate listening to my own voice.
He's gonna be so confused.
Anyway, alright, so yes, time is a social construct,
Yes.
not relative to all the universe. So, anyway, alright, so net displacement, okay, or a sign difference, okay, net displacement, okay, net, okay, so let's think about money. Let's go fishing, okay, because this actually works out the same way, because a lot of people have trouble with this when you do your finances. If I go fishing, okay, I'm like, yeah, I got 40 fish, okay, some of them got away though, okay, your net fish is the amount that you actually keep. Ones that actually stayed in the net. So that is your net. So now there is your gross income and your net income. So let's say, for instance, you work at Whataburger, okay? You have a gross income and you have a net income, okay? Your gross income is what you make total per hour, and your net is what you bring home.
After taxes and all that.
Yeah, after all that.
After taxes.
Yeah.
No.
And so, yeah, and so if you think about it in terms of fishing, net is what you bring home. Okay? So finances. So net displacement would be, okay, sign distance of an object whose motion begins at t equals a, ends at t equals b, given by this, the total distance travel, okay, net displacement. Let's go back to my douche bros comment. My douche bros. Okay, I'm walking from here to douche bros. It is 1 mile from here to douche bros, okay, and then I walk back. What is my net displacement? 0. Okay, I didn't go anywhere from where I started. Okay, I'm back at the very beginning, right? Okay, this next one would be total distance, would be there and back, which would be my 2 miles. Does that make sense? Yeah, there we go. All right, if v of t is greater than 0, for a less than t less than b, then the net displacement and the total displacement traveled are equal. Okay. So, these things are important. You gotta pay attention to what they're asking for all the time. So total and net. Total is absolute value. Net is just derivative or antiderivative of the velocity. Okay, interpreting interval involving rectilinear motion. Object rectilinear motion is motion along a horizontal line with velocity. Okay, there we go. There's my velocity, meters per minute from 0 to 6. Write my integral first. Find the net displacement of the object. Interpret the results in the context of the problem. So, let's go ahead. So, I'm going to have integration. So, integration from 0 to 6. Okay, and that's going to be 3t squared minus 18t plus 15 dt t.
Wait, wouldn't that's the velocity? Don't we have to do the mt derivative?
What? No.
No.
What?
What's integration?
Integration.
Yes. So we're integrating.
Oh yeah, we are.
Yeah. It's all right. All right, so let's go ahead. So from this information right here, let's go ahead and do this. So like I said, always do my variables first. So that's going to be t to the third, and it goes over 3, which is going to cancel, right? And then it's going to be minus, it's t squared, right? T squared, so there we go, 9t squared. And then this is going to be plus 15t. And from 0 to 6. Okay, so 0 to 6, that means it's going to be let's top minus bottom. My bottom's going to be 0. So let's see, that's going to be 6 to the third power. That's 216 minus 9 times 36 is, huh? 260? 36 times 9, something with a 4, right? Okay, so, hold on. 216 minus what? 324?
Yeah.
Okay, I'm sorry. 324 plus 15 times 6 is? 90? All right, so let's see. I end up with, looks like it should be a negative, right?
Yeah, negative 18.
Negative 18. All right, now, units.
Meters per
Ma-
minute.
Huh?
Meters per minute.
No.
Meters.
Why meters?
Because that's the answer we're looking for.
I started with velocity, which is meters per minute, right? And when I take the antiderivative of that, I'm going to the position, right? And the position is not a velocity, okay? Position is just distance right there. So it's going to be in meters. Just like if I were to take the derivative of velocity, if I take the derivative of the velocity, I would get meters per minute, okay, per minute squared, okay, because that's every minute there is a change of the velocity. So it is a double, like that one. If that helps, kind of. Okay. All right. So let's take a look. Now, in context of my problem, what does that mean?
The net displacement is
That
negative.
means
No, it's 18 meters. It can't be.
you
it
went
can't be
back
negative.
18 meters.
It's
Yes, you went back 18 meters,
Yeah,
right?
but it's still like distance traveled, right? So it's still gonna be positive.
That's going to be the total distance, right?
This is that.
No, the total distance would be something else, no? Total distance would be everything.
Total distance is the absolute value.
Because total's like you don't. You add all of the distance.
Oh, total is.
Like
Oh.
like if you went on your round trip and you counted all your miles.
We're going to do that, okay?
Oh.
All right. Now, we're going back to this though, because I haven't finished. I haven't done this yet. All right. So now this one's going to be my 18 meters. Okay. I'm 18 meters from where I started. Okay, in the other direction. Okay, let's say I started going forward, but instead I went to Douche Bros and then I had to go to the copy room. So I am actually in the opposite direction of where I was heading in the first place, right? Okay, so now for this next part right here, it's kind of tricky because it's the absolute value. Okay, absolute value. I cannot just take the absolute value of this. I need to find where my zeros are first. Is the next one here? Yeah. All right, so my function was this. So what was the function again? 3.
T squared minus 18t plus 15.
There you go, right? And we said from 0 to 6, right? Okay, this is probably going to be the one that's going to get most people. When I see that absolute value, okay, now, think about it real quick. What does it look like if my function is an absolute value of x? Yep, there we go, like that, right? Absolute value of x. There's a pointy point on the very bottom, right? Okay, so that's the absolute value of x. So it changes direction somewhere in there, right? Especially if I'm starting off with a positive and it's going to a negative, right? So in relation to my last problem, I'm starting here, I'm going to douche bros, and then I'm ending 18 meters back over in the copy room. Okay? So I went further backwards from the direction I started. But now, I want to know where it's changing direction though. It's going to change direction because if I think about it, my net displacement, I start here, I walk to douche bros, and I come back. My net displacement is 0. Even though we know that I turned around over there and I came back. So I have to have a positive value from here to there, right? And then I figure out where that is, and it's also a positive value coming back. That's the positive value that's going to be the absolute value there. Okay? I have to absolute value that negative distance, the negative velocity. So that's the piece I got to get. So we got to break this up and find out where it's going to change direction. Okay? So where it's going to change direction. So now, think about it. If it's changing direction, what do I end up with? Yes, I should end up a 0 from the derivative, right? Okay, so velocity, right?
Speed goes to
Yeah.
0 and then
Yes,
it
thank you. Speed goes to 0, and then it changes direction, right? So we're starting with the velocity here, right? So this is the velocity. So I'm setting my velocity equal to 0, and then I'm going to try and work it out. So let's do some factoring here. So take out a 3, and I'm left with t squared minus 6t plus 5. And then it's going to be 3 parentheses. Now, what are the factors of that?
-3, -2.
-3, -2. So it's going to be t minus 3, t minus 2. So t is 3 and t is 2. So I have 2 places where it changes direction, right? Okay. I have 2 places where it changes direction. So I have to check both of those. So what could I do to try and figure out which one's positives and negatives? I can plug it in, or
Take the derivative again.
yeah, the second derivative, that would actually, take a derivative of this, right? Derivative of the velocity is going to tell me what the concavity of this is, right? Okay. Let's, for the sake of, I am going to do my number line though.
Oh, I forgot.
There we go. So that's my interval I'm using, right? So we're plugging in numbers into there. So if we're plugging it into the velocity, think about it. Okay? I want it to be positive, right? Okay, so just plug in numbers in between, and it'll tell me where my velocity is going to be positive, and then where it's going to be negative. So right here, from 0 to 2, plug in 1. If I plug in 1, I get, is this a negative here? Yeah. Is this a negative here?
Yeah.
A negative times a negative is?
Positive.
So right here, this is going to be a positive velocity. Now, next one. So in between 2 and 3. 2 and 3, I'm going to put 2.5. So if I plug in 2.5 to my first one here, that's going to be negative. If I plug it into my second one, that's going to be positive, right? Positive. So we have positive and negative, so that's going to be a negative. Now again, between 3 and 6. Between 3 and 6, let's go ahead and plug in 4. So if I plug in 4 here, this is positive. Plug in 4 here. So 2 positives give me another positive here, right? There we go. So I'm going to have to break this up into my different parts, right? So it's technically going to be the integration. It's the integration from 0 to 2, right? And it's going to be my, what do we call this? This was a v of t, right? So I'm going to just write it as v of t because I want you guys doing this. So v of t, right? dt. And the next one's going to be plus, right? So we're going to absolute value this next part. It's absolute value of whatever we get for this of my 2 to 3 of v of t dt. Yes? Absolute value of that. And my last part of this is going to be from 3 to 6, right? Because that one's positive right there. So positive velocity there. So it's going to be plus integration of from 3 to 6 of v of t dt. So the absolute value ones aren't as easy as just, making your answer positive. You have to find out where it changes because we're going to have a total distance. So every time we talk about absolute value, think of me walking from here to Douche Bros and back. Okay? My net displacement, I've gone nowhere. But my total distance traveled would be my 2 miles because it's there and back. Okay? So now I'm going to stop the video on this because I want you guys to have like the 5 minutes. I want you guys to solve this one right here. Ugh.